And we are live. If all is well, people on YouTube, I hope you're watching. I don't see anybody watching actually. The watch count is literally at 0. So I hope there are actually people there. Maybe because the meetup is still down, that people can't find the link. Ooh, that's a bit of a bummer. People, if you're following this, yeah, there's 9 people following. So now there are people. All right. If you're following this and you see us on YouTube, can you leave a comment in the chat so we can see that we're not just talking to ourselves the entire night? Yeah. Okay. All right. Awesome. Welcome everybody to this 42nd Data Science Leuven meetup. Unfortunately, we're back remote. We're not doing physical meetings anymore. Although technically, I think we could still do it if we stay below 200 people. But then, kind of had a struggle if hospitals are full and they have to postpone operations, then it's a bit weird to bring 100 people together, I think. So we're going to wait with that until the COVID situation is a bit more under control. To counter a bit the fact that we're all back in our own homes or offices and not together, we did arrange for all of you, if you wanted to get some beer, and I don't know how many did, but I have here a beer with me, organized by Jellert. So Jellert, thanks for delivering the beer. I'm at least going to enjoy a beer while we're having the talks. This one is an IPA. I've never had this. Is literally, I opened it a minute ago, so I hope it's going to be good. The 42nd meetup, I don't know, I asked a question on LinkedIn, like, do you know the answer to, that 42 is the answer, now what is the question? And I don't know how many people got that, but it was a reference to the Hitchhiker's Guide to the Galaxy, where a big, massive computer calculated that the answer was 42, but they forgot what the question was. So that's also maybe it's a good summary of this meetup. It's a bit special, by the way, because we don't have 1 or 2 or 3 or even 4 speakers. We have 6 speakers all here with us, but they're going to speak in pairs. So it shouldn't take up more of your time than usual, I would say. I'll share my screen a bit to introduce the speakers to you. Let me do that. Share screen. Yeah, it's coming. All right, there we go. This was still, boom. So who do we have here? The first speakers of tonight will be Jellert and Simon from Atlas Copco. They're going to talk about AI in a production environment. So Jellert doesn't only provide the beers, he also provides the talk. So thanks for that. And then next we have Sarah and Lander from Telenet. They're going to talk about data science in a rapidly changing world. And then finally, Alexander and Elle. Elle is not on the picture here, but apparently she doesn't have a picture on LinkedIn. So, but you'll see her in a bit. From the Lijn, they're going to talk about how busy it will be on the bus. There's a story behind the druktebarometer. I don't know what that is in English. But those will be the talks for you tonight. Besides the talks, we also have one very pleasant announcement. So we put a call out a couple of months ago, I think, that, hey, we're looking for extra organizers because 2 of our organizers left the team. So we're looking for fresh blood. And I'm happy to announce that we found fresh blood. So welcome to the team, Sarah. I don't know if you want to say a word to the group. Maybe I'll stop sharing my screen again. And then, but Sarah, welcome. And it's a pleasure to having you on board.
Yeah, thank you. I did not prepare a speech except for the one I'm giving for my talk. But it's nice. I mean, I followed the meetups for quite some time already. It's nice to have a community going there. So I'm more than happy to help keep growing that community.
Cool. Welcome. Hopefully we can do a lot more meetings together. And yeah, thanks for joining the team. In fact, maybe immediately also a call out to where we want to be with 6 organizers. And after COVID, 2 of us was like, yeah, my life changed a bit. I don't want to do this anymore. So we're now back with 5 with Sarah on board. We're looking for the 6th one still, right? So if you feel like, I want to help organize Data Science Leuven, there's literally nothing in it for you. There's no money. There's only, we only ask you for your time, but it's fun to do. We get together from time to time. You meet a lot of interesting people in the data science world. So as I said, Alexander, it's not just about the data, it's also about the people. So with that being said, I'll stop talking and I'll give the floor to the first speakers, and that was Jellert and Simon. The rest of the speakers, I'll move you back to the back room or whatever. So I'll remove you from the talk. And then Simon and Jellert, you're good to go, right?
Yes, I should be sharing my screen by now.
Yeah, just a sec. I have to put it on the screen still. I see your screen. Yes, I see it. This one?
Okay.
All right, you're good to go.
All right, perfect. Thank you, Chris. So, as already mentioned, Simon and myself tonight will give you an introduction on how we do artificial intelligence in a production environment here at Atlas Copco. And of course, we'll introduce Atlas Copco briefly, as well as the project that we're working on. And we'll then dig a bit deeper into the development process from a high-level perspective. And then Simon will take over and show you some diagrams on the technical implementation. So we'll dig a bit deeper under the hood to then finally end with the current status and next steps. But first, let's get acquainted. So who's Atlas Copco? Well, it's a 148-year-old global and industrial company. So it's a huge company with a highly innovative spirit. We have about 40,000 employees and we have a production facility in 71 plus countries. And our customers, we have them in a range of different businesses in more than 182 countries. The entire group is split in 4 business areas. So we have compressor technique, we manufacture compressors. We have vacuum technique, which manufacture vacuum pumps. And we have industrial technique. They manufacture power tools. So you can imagine that as like the screw tools or your typical drill, but then not electrically driven, but using compressed air. And then we have power technique. They manufacture, amongst others, mobile compressors. So that's Atlas Copco. Well, who are we? So myself and Simon, well, we work in the smart factory team, where we basically do anything related to Industry 4.0. So basically any buzzword like connectivity, 5G, IoT, data, AI, those kind of things is what we do. For me personally, it's mostly artificial intelligence. I've been working there for a little over 2 years now, and I have 6 years of experience in the data space. And as Chris already mentioned, a little fun fact, I brew my own beers. By the way, Chris, I'm not sure if I should be charmed or offended that you gave me a call to provide beers for the virtual meetup, only to realize 10 minutes out of the call that you still had a spot open and we could actually present something as well. So that being said, Simon, I'll let you introduce yourself as well.
Yes, thank you, Jellert. So my name is Simon, and I joined Atlas Copco about 1 year ago. I worked a year and a half as an intern at the medical device startup before joining this company. And in a smart factory team, I'm mostly working on data science projects using computer vision on the edge. So my academic background is in industrial engineering, IT, and electronics. And outside of work, photography is one of my hobbies.
All right, so with this introduction out of the way, we only have to introduce the project. So what is it that we are going to present today? Well, it's all about quality inspection on our rotary screws, which are basically the heart of a compressor. On the picture on the right-hand side, you can see one of these screws and some black markings on that screw. And these black markings are exactly what we're looking for. So those are the defects. And we can't really check these defects before we start our processing because it's something very specific to our process. So we buy our material from a supplier and then take away part of the surface material to give it the predefined shape that we have. And that's when these defects become visible. Now you may wonder, why do you need an algorithm? Well, that's all because of automation. Previously, we had one operator responsible for one machine. So that person could really look at every single part that was being produced. But now an operator is responsible for multiple machines. So that means that some parts are actually never being touched. And that's why we need this automated quality inspection system. And what does that look like? It's exactly this. It's an active vision system. So that means that, let me get my laser pointer. So this is one of our finished products. A robot takes it out of the machine and puts it into the vision system. And it puts this rotor, if you look closely, you can see a rotor right here. and puts it on a rotary stand, and that makes the rotor rotate. While this rotor is rotating, this dome, which contains lights and cameras as well, is being repositioned over this rotating rotor, and then a bunch of pictures are being taken. These pictures are being sent to an algorithm, and that algorithm then analyzes that picture and comes back with the result. Is there a defect? Yes or no. If there's a defect, then the robot will put this specific piece on a separate bench for audit for further human inspection. If there's no defect found, then it's okay for further processing, and it can go on to assembly. And this is one of the pictures of the current system. But if you look closely, you see that it's not just defects. There's also some other things. And in this picture, you can see an oil droplet. And oil is there. It's specific to our manufacturing process. We just work with oil. And it's not always easy. Well, for us, it's easy to see the difference. But for a computer, it's not always easy. And it's not just oil droplets. There's more as well. Sometimes there's dust, some metal particles, these kind of things. And we all have to distinguish these things and only find the actual defects. So far for the introduction. Let's have a look at how we actually tackle this. So a bunch of approaches were tested, and the first approach happened, I think it started 4 years ago already. Before I arrived at Atlas Copco, a third-party solution was bought, and it was both hardware and software. It's actually the station that you saw in the previous slide, but the software was insufficient. So it was using regular vision techniques, so based on pixel values, gradients, and some thresholds. But every other day we had to go and tweak these thresholds depending on the weather. So our automated system was not really automated anymore. So there was no use. So the first thing we tried internally was to do a classification. So we just tried and classified these images, as you can see one on the screen, as being faulty or not. But that was insufficient as well, as the defect that we're looking for, that particular feature is so small compared to the entire picture. So finally, we ended up with an object detection approach, where we just gathered a lot of images, labeled them, picked a certain algorithm, trained, tested, and then iteratively repeated the entire flow to, in the end, come up with the result, as you can see on the bottom picture, where the algorithm draws some bounding boxes on the defects and oil droplets in this case. So the typical process, we have some images, we select the interesting area, which is the body of the rotor, and we lower the resolution to increase processing times. Then we labeled them. We did that ourselves. It was a very fun task to do. We then trained the algorithm to finally containerize it and distribute it to our shop floor. Of course, with every iteration, there's also a test happening on images that the algorithms have not seen before. So we had about 100 images, and here you can see our progress. So we started with only 132 training images with a resolution of 256 by 256 pixels. And even with this low amount of training images and this low amount and this low of a resolution, we already got to an accuracy of 87.5%. Although on the right-hand side here, you can see that there is a lot of false positives. So that means unnecessary work for our audit department. So that they're actually checking a rotor where there's nothing there. So we increased the number of training images, we increased the resolution, tried a couple of neural network architectures to finally achieve an accuracy of about 95%. And as you can see, these false positives decreased a lot. Also, while testing, we noticed that our own work, our labeling was not perfect. So the accuracy is actually a little bit higher in every case. You may now wonder, how did you train this? Well, we really started on our laptop. The 132 images and a low resolution, it was still feasible, although that already took quite a while. And then we did some experiments with some virtual machines, with some GPUs, and now made the decision to move everything to the cloud. The deployment hardware in this case, as mentioned, we containerized it and then deployed it. It's just a shop floor computer, the same computer that an operator uses to interact with the IT systems, the MES systems. So looks good, but we have to be honest, it's currently not used in production. And we all know that a lot of data science projects fail. I didn't fact check the 85%, so don't get me on that. And I knew this beforehand, and I wasn't going to be one of those guys, but I have to admit that I was, and it's because of a couple of reasons. First of all, is the object and the pictures itself. So the data collection and annotation, it takes a really long time, and it's also quite difficult because you need a 360-degree check. But most of all, it was the shape. As you saw in the pictures, it's not the easiest shape. It's a very shiny material as well, and because of the grooves in that object, it casts shadows, and there's quite a distinction between the inner and the outer diameter. So the depth of focus of the cameras needs to be quite large as well. But all these problems were actually tackled, so that's fine. The biggest reason why it's not in production is the integration. So the cells that we have at Atlas Copco, they are often designed years ago. The machines that we have are really expensive and are being used a dozen of years. So there's not a lot of space for a lot of hardware. It was not thought of that we would need some inspection station 10 years ago. And then finally, it's the external partners. So we have a lot of external partners. We have a robot supplier, we have a machine supplier, we have a machine vision supplier, and then we have our own software. So there's a lot of alignment needed and a lot of different skills at each of these partners, and that was actually the breaking point. You can imagine that integrating your own software into the software of a vision supplier because you didn't like their software is a quite hard task to do. So currently the setup, it actually works, but it's only being used as a demo environment and as a golden reference for the next steps that we have been taking in this project. So I guess you wonder, now what? We've made the decision to do as much as possible in-house and downscale as much as possible on the hardware to make it fit into the cell. And this is also where I'll hand over to Simon. He will explain a bit further on what we've done as next steps.
Yes, thank you. So we started with doing research on how we can use the vision AI model on a small edge device and integrate it with the communication of the cloud. So now we are indeed taking in-house as much as possible for the hardware and the software. So next, I will focus more in the presentation on using the code that is running in the cloud and then gets deployed on the edge device. So further, I'm going to talk more about the technical implementation we've performed. And there are a lot of providers for the different kind of edge devices. So we are at the moment testing some of these that are shown on this slide. And by comparing the different benchmarks of the smaller edge devices, NVIDIA actually had a faster inference speed than the neural compute stick of Intel or the Google Coral device. So those from NVIDIA are also more flexible on the amount of deep learning frameworks that it supports. And that is actually why at the moment we are using the NVIDIA devices on this use case for testing it in production. But this is of course not a final selection. Then the next slide shows the setup we are using for the quality inspection. So an operator will place the rotor in the quality inspection cell. And when the operator then presses the star button on the HMI display at the top right, the PLC for steering the cell will be triggered and the rotor will then start to rotate. So now a signal is sent to the edge devices, to the edge device, and this edge device is connected with 3 cameras, and these are placed in the back of the cell, and they will start taking the images. And then after the rotor has made a complete turn, the trained AI vision model then shows on the HMI that detected defects in the rotor. So as I already explained, we are using 3 cameras connected through USB with an edge device. And we have tested both the Jetson Nano and then the Xavier device. So the Xavier, that is the one on the right, has a better GPU and also supports a higher USB bandwidth than the cheaper Nano device that's on the left. And so for this use case, we are using multiple cameras. So that's why we selected the NVIDIA Xavier. And we're also using 2 Docker modules, so one for the camera and one for the AI vision algorithm that is running on the edge device. And the camera module captures and processes the images using a thread and will then send the images to the vision model using a post request. And the AI model that also contains the REST server will then listen to the request sent from the camera module and will then perform the object detection on the images. And then the second part of the technical implementation is the connection to the PLC. So another company actually provided the hardware for the inspection cell, but all the software for the communication with this PLC is done by our team. And the PLC gets triggered by the HMI for steering the cell and then turning the rotor. And as you can see in the middle, we are using the OPCOE as the protocol for the communication between the PLC and the edge device. So an OPCOE is actually a protocol that allows for different hardware setups and different operating systems to communicate with each other. And then finally, the HMI shows the result to the operator. And then the next part of the technical implementation is the communication to the Azure cloud from the edge device, so that we can deploy the Docker modules from the Azure Container Registry and also store the images in the Azure Blob storage. And we made use of the IoT Edge for deploying the modules, and this also provides cloud-based monitoring and reporting of the edge device. And the Azure IoT Edge actually has 2 components. So the first, the IoT Edge agent, is used for deployment and the monitoring of the modules. And it's also responsible for downloading the deployment manifest from the cloud and then pulls all the container images from the Azure Container Registry. And the deployment manifest tells the Azure IoT Edge runtime what modules to deploy and the correct options to start each Docker with. And then the second part is the IoT Edge Hub. This manages the communication between the different modules and also the communication from the cloud environment to the edge device. So yeah, indeed, I know this kind of looks like a marketing slide from Microsoft, but yeah, this is actually the way how we are implementing it. So the image on the right is a less complex version that summarizes with the Azure pipeline used on the left. And as you can see, we are using the Azure Devops environment for creating the pipelines. So we first started with only using the Azure ML workspace for training the model with image data from the Azure storage. And once this was successful, we then moved to using a build pipeline that triggers these training scripts we created in Azure ML. And the model is then converted in an ONX format and is stored in the Azure ML model management. So the second pipeline then gets triggered when the newly trained AI model is registered, and this pipeline will then build and push the models into the Azure Container Registry. And then finally, the third release pipeline will enable to easily deploy these Docker modules using the Azure IoT Edge. The project has had some technical challenges, so we are not just there yet. And for the roadmap, the current status is that the cell is now in use, and we have proven that the technology works, and the technical backbone is about ready. So next steps are that we need to gather more images. Now that we are using 3 cameras. As we are already explained, the proof of concept only uses 2 cameras, and these were also placed in another position. So the data cannot be used again. And then we have to train a new AI model, deploy it in production, and yeah, we will have to iterate this process until we get the best possible accuracy. And that was our presentation. Thank you for listening. Any questions?
All right. Thanks a lot, Simon and Jellert. I'm gonna wait a bit until some people ask a question, because there is some delay between when we talk and what is shown on YouTube. So let's see if there's some questions popping up. There was one question already, by the way, for Jellert. Jellert, and by the way, you're still muted, but Killian asks, like, do you also apply machine learning and condition monitoring in the brewing process?
I was considering doing so, but currently not yet. No, I was considering finding out what beers are sold in what parts of the country, and then go and sell there. But that data is hard to come by.
It is. Okay. All right. Cool. Let's see if there are some other questions. While we wait for questions, maybe Jellert, you said something like we're not in production yet. Is that still the case, or are you like trying? You're running in production right now?
Well, the first setup that I spoke about, it is actually positioned in production, and when we want to do a test, we can actually use it, but it's not being used by an operator today.
Okay.
And the second setup that Simon was talking about is being built. Well, it is actually built and it is in use. But since the cameras are in a different position, so in the first setup, they were both looking directly at the rotor from above, and now we're looking at them from a specific angle. So we first need to have a separate model that cuts out the interesting parts of the rotor. And that's what we still need to build now, but we first need to gather these images. The cell is in use since last week, so we don't have enough pictures to train that second model yet.
Okay, cool. And then maybe one follow-up question. I saw you use containers a lot in your pipeline. Was that the idea from the get-go, like we're going to do Docker and let's go, or did you add that later, and what was the reasoning behind it?
It was always the purpose to containerize it and use Docker. I did make a mistake in the very beginning by not doing it from the start. So I was just training this model on my own laptop. So it's just a Windows laptop using PyCharm and an Anaconda environment. But transferring that to Linux containers, that was quite a hassle. So that took some time. So my advice, if you want to do that, start from the beginning using a Linux environment in containers, and then you won't have a problem. All
right, cool. Thank you very much. Well, I see there are no further questions. So with that, Simon and Jellert, thanks a lot for your talk. Let's switch to the next people.
Yeah, you're welcome.
All right, I'm going to remove you guys from the stream. And so next up was Telenet. So that's Sarah. I'm going to add you, and Lander, right? All right, let's turn off the banner here. Hide. All right, so Sarah and Lander, the floor is yours.
Thank you.
Yeah. First, getting my screen sharing going on.
Yeah, I see it. It's coming. There it is.
Nice. Okay. Hi, everyone. In this talk, my colleague Lander and I will talk about data science in a rapidly changing world. And to know why we at Telenet call it data science in a rapidly changing world, let's just have a quick look at this timeline of things that are happening within Telenet. And I definitely do not need you to learn this by heart. There will not be a quiz afterwards. But I want to highlight 3 things that are happening here at Telenet. First of all, we have a lot of new product lineups. And the last couple of years, the amount of product lineups has even been accelerating. For example, in 2016, we launched Wigo. 2019, we added Hugo. And now, this year, they have both been replaced by our new product offering One. Next to that, we also have products or features that are becoming completely obsolete. For example, 2013, we launched String, which allowed you to do a phone call using your fixed internet line. And now 2021, we actually have just, I think it was in June, disabled it. Next to that, the third thing that's going on is that we're also acquiring other companies. For example, in 2016, we acquired Base, and the year after, 2017, we acquired SFR. For those who don't know that, it's actually a French telecom provider, but in Belgium, they had a small client base, mainly in the Brussels area. So this, of course, poses some challenges, not only for Telenet as a whole, but definitely also for data people working at Telenet. So what challenges do we have and how did Telenet solve them? Well, first of all, organizationally, we changed from a more silo/department structure to chapters and squads. Next, the data people need to be aware that we sometimes need to deal with the cold start problem, meaning that we need to be able to do intelligent targeting with no or little data available. Also, the fact that the world at Telenet and even the world around us is changing. Everything we do needs to be able to handle that flexibility. For example, when we build models, we need to be able to predict with changing and sometimes even unknown circumstances. Next to that, there's also the timeliness of both our models and our features. In 2016, we built models for our WeGo lineup, which now, with the launch of one, have become obsolete. So we need to think about maybe there's a more future-proof way of modeling. Same holds for our features, where some of our features seem to have an expiration date. Going back to the Tring example, when it was launched in 2013, we had a flag indicating whether a client had Tring or not. Probably back then, this was a good proxy for the digital savviness of a client. However, now, with Tring disappearing, we don't have that flag available anymore. What does that mean for everything that relies on it? So, unfortunately, today I've only got 20 minutes, so I'm only going to focus on the first three parts. So we'll talk first about the organizational structure, an agile way of working. And of course, probably you're already familiar with the term agile, but how is it implemented at Telenet specifically for data people? Next, for the cold start problem, I will quickly discuss the one launch use case. And for the flexibility part, my colleague Lander will discuss the one connectivity use case. So let's start with this agile way of working. And unfortunately, if I say agile, there's also quite a lot of terminology behind it. So before I can really go into details into how it's implemented, I need to explain you guys some important terms. First of all, Telenet is divided into tribes, and each tribe focuses on one specific functional domain. For example, we have an entertainment tribe focusing mainly on the content packs. We have a base tribe, we have a residential get, grow, keep tribe, and so on. Your tribe determines what topics we are working on. Within each tribe, there are then multiple squads, teams of different profiles that can work on projects from beginning to end. They each focus on one specific team or project determined by the tribe. Now, an agile organization is typically a matrix organization. The tribe and squad are one axis of that matrix. The other axis is your chapter. The chapter actually contains colleagues with the same skills, and the chapter determines how topics identified by the squads will be tackled. For example, I'm a data scientist. I belong to one specific squad in the entertainment tribe. They determine what projects I am working on. Next to that, I also belong to the data science chapter. They determine how I will do those projects. What tools do I use? What best practices? What processes do I need to take into account? And so on. There's also one exception, the Center of Expertise. Those actually combine colleagues with rather unique or scarce skills. And rather than putting them into one squad, they support multiple squads or tribes. Different related chapters and COEs can additionally be combined into a chapter area. So with those terms out of the way, we can now see how Agile is implemented for the data people at Telenet. First of all, we have a data and insights chapter area, which unites about 200 data profiles. And of course, If you want to be able to do anything with our data, we first need to turn that raw data into a format that is more suitable for other purposes. This is done by the data engineers from the data engineering chapter. Next to that, we also have an insights and reporting chapter to translate that data into actionable business insights, a CRM and market research chapter to translate that data into personalized experiences for campaigning and to leverage research data for actionable insights. We have a data science chapter. You guys probably all know what data scientists do. And next to those 4 chapters, we also have the Architecture and Governance Center of Excellence. They transform businesses to adopt a data-first thinking, and they contain data architects and data governance experts. The Data and Insights chapter area has a close collaboration with the Data Strategy COE, or some of the profiles from the Data and Insights chapter area even move to the Data Strategy COE, like Lander, the other colleague that will talk today, did just recently. The data strategists drive the data strategy, boost transformative value cases with analytics, and act as an internal analytics consultancy. So that's the one axis, the chapter and chapter area. The other one, tribes and squads, what does that look like for our data people? Well, as I already said, a COA is something completely different. So they're still put aside into that same COE and they transform. Next to that, data people can either enable one of the business tribes or be in a data acceleration tribe to build, to boost, or to support. Build, those are actually the data engineers building the data and analytics platform that can be used to monetize our data. There are multiple build squads, each focusing on their own specific data domain. Boost, support, and enable are actually the 3 roles where a data scientist can be assigned to. So I will dive a little bit more into detail in the next couple of slides. This is a distribution of our data scientists over the different squads. The Boost squad, the support/business insight squad, and the enablers in the business tribe. As you can see, most of our data scientists belong to Boost, 3 belong to business insights, and there are 4 enablers in the business tribes. I'm the green entertainment enabler. Also, this slide accurately represents the male-female distribution within our chapter. So we do miss some ladies, and I can say this because I'm a lady myself. Now, to get a bit more into detail into what those different roles/squads do, let's first dive into Boost. The Boost team, together with the business tribe, jointly identify high-value cases using analytics. Next, a multidisciplinary data and insights team steps into the business tribe to create an MVP using analytics and to get learnings from experimentation with it. Often, this MVP solution will be industrialized by the build squads, making sure it's available for the day-to-day activities of the squads. Next, the Boost team moves on to the next topic, which often has close links to the previous topics because we learn from what happened there, while the business tribe assumes full ownership of the MVP solution. Business Insights has data scientists, market researchers, and insights analysts available. They mainly work on cross-tribe initiatives. For example, one of their last projects was the customer intimacy case, where their goal was to provide business with a clear and actionable set of metrics that can be used to steer towards a higher customer intimacy. Next to that, they also support tribes and squads where no dedicated D&I resources are available. And last but not least, they also drive data and analytics innovation. They're the first to experiment with new data science techniques that could potentially hold value. Business tribes, where it makes sense, can have dedicated D&I resources available as enablers. The chapters ensure that the talent is available and best allocated, for example, based on interests and experience. Our enabler CRMers, insights and reporting analysts, and data scientists Make sure that reporting, analytics, models, and campaigning are available and embedded into the day-to-day activities of the business tribes they support. Next to that, they also act as a bridge between the data people within the data acceleration tribe and the business people from their business tribe, speaking both languages and thus being able to translate from one to the other. Last, but definitely not least, because I'm an enabler for entertainment myself, and this is the part I like most about my job, we get to train our business-oriented tribe members in data literacy on a day-to-day basis. For me specifically, this means I'm doing a lot of ideation workshops to turn entertainment into a data-driven entertainment. So, to sum it all up, as a data scientist, you're either boosting squads, creating an MVP analytics solution and learnings from experimentation. You're either in business insights, where you mainly focus on cross-tribe topics and data and analytics innovation, or you're an enabler, where you're acting mainly as a bridge between business and more data/technical people. Now, what kind of cases do we work on? Well, we actually work in quite a lot of areas. We've boiled it down to 6 macro cases. The first one is segment of one. This one is all about hyper-personalized marketing, proposing the best fit product or bundle to our customers. Next, there's customer relationship transformation, where we believe data can be of high value in identifying and remediating the pain points in our customer journeys. There's data-driven entertainment, where we aim to provide our clients with the best entertainment experience possible by using a personalized approach. We also want to grow our SME and LE business by leveraging our data. This is the one experience macro case. One connectivity, which is what Lander will talk about, is all about our network management, both fixed network and mobile management. And then we also look at strategic workforce intelligence, which is HR related, getting the right person with the right competences at the right place at the right time. So, that being said, I can now turn to the One Lounge as an example of our cold start use case. So, we had no data available at the launch of One, so what could we do? Well, we actually, and that will probably not be a surprise, implemented business rules using our customer data. But we did leverage some of the existing models there. Because by customer data, I mean telco spend, because we definitely do not want clients to spend more on their telco than they are doing now. Telco usage and churn risk and likeliness to switch. The telco usage was used to determine a customer needs. For one, it actually boils down to 2 big blocks. What internet speed do you need? And we definitely do not want to recommend a product that has a lower speed than your current one, unless you're not using your internet that much. And then the other block is your TV experience, where in one you have the option between the classical digital TV via your TV box or the streaming option. To determine which option best fits the client's needs, we looked at his current streaming behavior on his TV box, because you do have the Netflix app there, and also the use of his classical TV box features, for example, recordings. But the real intelligence was actually when we leveraged our existing models to decide who to contact. Likeliness to switch was something we determined by looking at the acquisition and cross-sell models of our previous lineup, meaning Wigo. Who is most likely to switch from one Wigo product to another? So, who is most likely to switch? Next, we also combined our existing churn models because we do not want to contact clients who are at risk for churning to propose them a new product. Now that One is actually launched, we're building new intelligence based on that data, but this business rule logic is still used as a benchmark. And with that being said, I can now give the word to Lander for the One connectivity use case.
Thank you, Sarah. Like Sarah says, I will now talk you to the one case or the one connectivity case. In this use case, we want to maintain the exceptional performance of our current network, especially in these changing times which we are experiencing right now with Corona. These changing times give us other circumstances which we need to overcome and be able to incorporate in our predictions. I'm of course talking about the effects of home working measures on our network, because as we all know, they go up and down during the year. Let me first give you an overview of the different cases we are working at Telenet for our fixed part of the network. I will do this with an analogy to driving a car. Our network consists out of 3 different blocks. You have the car, which is your personal device at home, like your laptop, which you are using right now to view this broadcast. The traffic of other people also using the car is very important, and that's the traffic part. And of course, the quality of our roads. In the first block, we want to improve the customer connectivity to our network, his in-home connectivity. Is the car running okay? Are all metrics working fine? Or do we need to help our customer with correcting those settings? This is the first block. The second block is traffic, because, of course, you're never driving alone. And if there are many people on the road, you have traffic jams, like we have every morning or evening in Antwerp and Brussels, and probably also other regions in Belgium. In our traffic, we have upstream and downstream traffic. This is, for example, people using their car to go to work and other people using their car to go home. They are on other sides of the road, so they are, in this analogy, upstream and downstream. And then, of course, you have the road you're driving on. Sometimes potholes need to be filled or lines need to be repaired. This guarantees the quality of the road, and in our case, the quality of our network. In this presentation, we are going to focus on the traffic of our fixed network. Let's first look at how our network is right now. You can move to the next slide. Thank you, Sam. We have the headends, which connect our network to the backbone of the internet and connects us to the Googles and the Facebook and all the big giants. And from the headend, we have fiber leading to our nodes, which on their term leads the internet through a coax cable, through amplifiers to amplify the signal again, and taps which connect the homes of our customers. The taps are those small mushroom-shaped sizes, boxes you see all over Flanders in every road and almost at every 5 houses. To upgrade our network, we mostly need to look at our nodes, so the stop between fiber and coax. And this is also the focus of our fixed use case. In order to tailor our network to our customer needs, we first need to understand how the customer and our network are related to each other. First, we want to identify our customer experience. What levels of utilization of our network, the traffic on our network, will impact customer experience? Secondly, we need to have a full technical and commercial overview of our network. We need a dashboard with all kinds of information for better ad hoc decision making. And thirdly, but definitely not last, our network forecasting. Can we predict the increase of traffic on our network on a more data-minded way, especially now during lockdown measures? All those steps will help us to foresee the right investment of the right nodes at the right time to guarantee an excellent customer experience. Let's discuss the 3 different points in detail. In the first one, we want to understand the drivers of customer experience. We want to link network performance to customer impact, which on turn will also impact the experience and happiness of our customers. More concretely, when a node goes into high utilization, there can be an increase in more latency, which has an effect on, for example, longer downloading times. As also package loss, which is when data does not reach its destination and is lost along the way. We want to understand what the impact is of those problems on customer experience. Unfortunately, we cannot show you any results of our interesting tests. But what I can say is that our network is running smoothly. The second item was the Nur360 Dashboard. This dashboard gives our colleagues a complete overview of all kinds of different features, like node information, utilization on the nodes, but also additionally, which is new for our colleagues, is information related to customer experience. This dashboard is useful within a wide range of use cases and also analysis within Telenet. And then, of course, we also have our last topic, the node utilization forecast. In the past, there was a general global traffic forecast of our complete network, independent of how the nodes are performing on themselves. This resulted in an under and overestimation of certain nodes' traffic. With the use case, we can transform the per node forecast to a more fine-grained forecast and enable us to do the right investments on the right nodes and especially on the right time. This will guarantee the good network experience our customers expect from us. In a later meetup, we will go into more detail about this and what we did to overcome Corona and all the other influences. So please keep calm, stay tuned, and dial in next time. Thank you.
All right. Thank you very much, Sarah and Lander. So for people in the audience, if you have questions, I'm going to put the ticker on again. Leave the questions in the comments. Thanks for that broad overview. There was one question from Bart. Said, "Hey Sarah, great presentation. When using personal data, who grants you access to that data? How long does it typically take before you have access to your data?"
I'm not sure what exactly is meant by that question, actually.
Okay.
Well, we do have a lot of measures in place about personal data. We have different levels of privacy, which we incorporate in our use cases and monitor every time. If we want to use new data sources in new use cases, it always has to go through the privacy board, which assesses the new data sources and also those cases. So we want to keep very privacy minded and also be very open to our customers. If they don't want us to use their data, we want to use them. And that's where the privacy settings are also for. Yeah. I hope this answers the question.
To me, it was clear. So well, Bart, if you have more questions, then put them in the chat. And then Istvan has two questions, one question with over two chats, whatever. He says, "Hey, Telenet puts a lot of emphasis on organization. I see that's okay as such, but the overlap between, say, data science, market research, and insights is so high. But I admit bias on this point. By the way, if you know, Istvan you're a market researcher, right, Istvan? I can say that, yeah. That you have the risk of over-fragmentation. I don't know if you see a risk of over-fragmentation by having such an organization. If so, how do you avoid that?"
Well, there's definitely things that are on the verge between insights and reporting and data science. But squad-wise, we work in this multidisciplinary squad. And for me as well, I typically work together with an insights and reporting analyst.
Yeah. Yeah, indeed.
Yeah, for Boost also, we are multidisciplinary. So you have data science, which is more relevant to modeling, and then market research will help us to define certain aspects we need to concentrate or what is important. And our insights and reporting will always help us to make that data science output more clear to business, but also work on other data analysis purposes, which are necessary for the organization. So within Telenet, it's kind of well divided, as there is sometimes indeed an overlap. But because of this structure and the different chapters, points are almost always well defined, who does what and how.
Yeah. Okay, cool. Bart says, thanks, Lander, for the clear answer, by the way. So that other question was also answered quite well. Maybe I have a question. I don't know if you were at Telenet before the reorganization, before they went to chapters and tribes and stuff, but I don't know if you can compare between the two, like what was better then, what's better now, because it's always interesting indeed. What I liked about this talk is you guys you don't have a data science team and a data engineering team. You have like a lot of data scientists and a lot of data engineers and a lot of business units. So you always have to split the cake somehow, right? So now you split the cake by doing the chapters and tribes thing. I don't know if you can compare to the situation before that, and if you can give some insights on that.
Yeah. We're both new at Telenet, so we joined after the transformation, to be honest. But what I do hear from a lot of colleagues is that this new way of working is very helpful for us to be very flexible. Also, new data formats and new way of working like Boost and Business and Insight pops up in this way, which makes us more performant and people can move to different places, experience more different things. So it keeps us very motivated and very new items. And if there's a new direction for Telenet we have to head in, it's also easy to be flexible to go that way without the silos. I cannot make the comparison with before, but I think there are a lot of possible positive things with this move. I don't know, Sarah, if you need to add something about your experience.
No, I'm also really new to Telenet, a little less than a year. So I also have no experience with how it was before. But I also get the same vibe from the people in my squad that are already longer at Telenet, is that it's now easier to quickly change. It's more flexible.
Okay, cool. We have one question from Peter. Peter asked, what is the balance between on-premise and cloud, and how is it evolving?
It's evolving. We're setting up tracks and experimenting with all different things. So we have a lot of use cases running on that. We try to be cutting edge and on the front road of those innovations, but also we're a big organization with a lot of data and a lot of personal data, where again, from the previous question, we need to incorporate and be very conscious about. So we need to keep all roads open and try to see what works best for us. I think even Chris, you're involved in everything. So.
I am just a meetup host here. Yeah. All right. I think with that, we can wrap up this talk. Thanks a lot, Lander and Sarah, for giving us some insights into how Telenet works at scale. It's interesting to see. It's a different topic than the typical topics we see, but it's super relevant for larger organizations. If you work in a larger data science organization in Belgium, we see the same things coming back, right? So it's good that you guys share the light on how you operate like that in Telenet. So thanks a lot.
You're welcome.
Thank you.
Thank you.
Then I'll add the other speakers, which is people from the Lijn, Alexander, add to stream, and Ella. Boom. Wait, no, one of the comments. So Ellen and Alexander, they will talk about the druktebarometer. I don't know, Alexander, if by now you have an English name for druktebarometer, but
it's a crowdedness service.
The crowdedness service. Okay.
Yeah, vehicle crowdedness service.
Yeah, no, but it's yeah. I don't want to mock it, right? It's. Don't forget also talk about the people behind the data. And then, I'll add to your screen, Alexander. I'll remove myself, and then you guys can go ahead.
I think Ellen is gonna.
Sorry.
Do you see my screen, Alexander?
No, sorry. I projected Alexander's screen. Ella, we don't see your screen yet, but it's there. Yeah, boom.
Okay.
Yeah.
Again. Okay, Alexander.
All right. So hello, everyone. I'm Alexander. I work as a data engineer and cloud engineer at the Lijn for 3 years now, and we've been working on a data platform. I'm gonna give you a bit of an intro and talk about the Lijn and what the technical side of things, and Ellen is gonna go in deeper in the model. I don't see the screen by the way, but I'll check on my homepage.
No, yeah, Ella, sorry, we don't see the screen. It's a black screen now. I don't know, maybe that's the slide.
Okay.
Yeah.
That's not a good thing then.
Yeah,
Alexander, I think it's better. Yeah, but I can't share it then, Chris. So Alexander, I think you have to take over.
Okay, sorry.
Yeah, no worries.
Difficulties.
Okay, then Ella, I'll remove your screen again.
Yep.
Yeah, there we go. And then Alexander will pop up again. A certain Joachim Knops is also complaining about no screen for me. Yeah, Joachim, it's coming. Is he always this impatient? I'll remove myself again.
So to continue, so we're going to talk about the druktebarometer. Yeah, it's the Lijn is a Flemish company, so we call it the druktebarometer. But inside in the code, it's our crowdedness service. Who are we? Who is the Lijn? I think most people know. So we're the public transportation provider for Flanders. We're not that big of a part of a small country. Still have we have a lot of routes, a lot of stops, a lot of data points, which buses and the trams are doing. So
Alexander, you don't see actually your presentation.
Oh, really?
You just see the first slide.
It worked before, no?
Yeah.
Do you need IT support? Yeah, sorry guys, maybe I just did a bit better. But if you do,
I can just
I think it's best that you share your entire screen, and then it always works. But I'll remove this again. Yeah, it's coming back. Boom. Yes. And now if you hit present, it should be fine.
Yeah, we have a lot of data points, which we are doing on a day. So a lot of departure, a lot of trips, a lot of buses and stops. On a year, 1 year, we do like almost more than 200 million kilometers that we travel. So that's quite a lot. We also have quite a lot of vehicles in use. More than 2,500 vehicles that we have ourselves. More networks, which includes the coastal tram, which is a very special one, and we also 2K vehicles from external operators, which we also try to use in our data products. So we also have, of course, a large amount of travelers. Most of them are children and less able in society, and also people who are older, don't have a car anymore. In 2019, we had more than 750,000 in abos, 20 million tickets and cards. So that's quite a lot, as you can imagine. With Corona, that went down quite a bit. It's still less than the numbers before, but we're steadily growing. So, but one of the issues the Lijn has, and I think most people know, is that with the LAN. There's also a very broad tendency of people being unhappy. So in this, our own numbers that we have from research and global research, only 6 in 10 people find the services of the LAN satisfactory. So we have a lot of frustrated travelers, and that's one of the things where we come in. So we are team Reizigersintelligentie, so travelers intelligence. If I have to translate it for you, Chris, we are already 3 years old, and we have like 2 main missions at the LAN. So one of them is client solutions, so helping the travelers to have a better experience with the LAN. So we try to collect data insights and transform those into a better service that we can provide to people. So we try to do that with tailor-made communication about, for example, canceled rides. So if you're standing at your bus stop and your ride is canceled, nobody likes to wait for no bus. So if we know you're going to take that bus because we know it's a favorite of yours, if you take that one a lot of times, then we can tell you this bus is canceled, and now you can maybe take this one, or you can find another solution. Other things we also are working on is order confirmation, stuff like that. We're working on a new way of letting people know when they do digital buys, and also, of course, the crowdedness score. So what is the actual what is the predicted crowdedness that there will be on a bus? So if you don't have to wait on a bus that will be super full, and so you can't really get on. The other part, so the second from that we focus on is business processes. So also converting data insights to do more efficient allocation of resources and then try to optimize some of the processes within the company. One of the things we try to do is to help in the decision making around scheduling for the buses. And the other one, which is a kind of big one, is we're starting up with getting to predictive maintenance of the buses. So now we're starting to collect all the data and getting all the electronic tracking into one big system, so we can do some flagging on that and see if stuff is broken or stuff doesn't really work that well anymore, and we can try to evolve to predictive maintenance from there on. We work completely cloud native, so we work on Azure, and we have a very, very broad stack. I think we almost touch every service there is on Azure. So it's a pretty classic data lake, data service that we do. We have a lot of batch stuff that we have a lot of data that we process in batch, and we have a lot of things we do stream processing on. We expose data in databases through APIs, through dashboards. We ingest data through databases and APIs and streams, and we also have an extra layer of data science that we started not so long ago, and that's where I'll deeper into. So one of the use cases that we did is the druktebarometer, so our crowdedness scoring service. And that's what Ellen is going to talk about now.
Yeah, it's not only one of the main products our team delivered in 2020, but it's also one of the main services, one of the most important services which were introduced to our travelers. It gives, or at least try to give, an answer on the question, how busy will it be on my bus or tram tomorrow? So first of all, why did we need such a service? As nobody should be surprised, these days, the main trigger was actually a well-known virus. On the figure, you see actually the daily number of travelers in 2020. And before the lockdown, we had around 700K travelers each day. After the lockdown, at the beginning of the lockdown, it dropped below 100K every day. And there it came in April, our question to deliver a crowdedness service. Why? Was it actually for the first time that the LAN was asked to build such a service? Twofold. Actually, the LAN was afraid that, too fast, Alexander. The LAN was afraid that as the lockdown was finished, that either the buses become as crowded as before, which was not a really good idea, or that people wouldn't dare to take the bus anymore. So by delivering such a service, it should encourage people to take the bus in case of a non-crowded bus or to reschedule when necessary. The goal, as simple as that, inform traveler about expected crowdedness on bus and tram. Crowdedness, not just a number, no, it should be some meaningful category to to the traveler and expected, this implies actually a prediction, because our travelers are not interested in how crowded it was yesterday. Now they want actually to know how crowded it will be tomorrow. So there we are with our goals and timing, of course, because we got the question in April, and we got a question to deliver it, if possible, in September, meaning within 5 months. And as good teams do, we made a plan existing of the 4 building blocks, which are depicted here. First of all, if you want to predict the future, you have to know the history. So we build up the historical occupancy. Further on, step 2, we determined a future occupancy, and based on that, we derived the crowdedness. And of course, the most important step of all, bring that crowdedness to the travelers. To start our historical occupancy. If we are today, what was actually the occupancy yesterday or another day in the past? And what do we mean with that occupancy? We made a small animation about it. So if we have a bus which drove from the first point to the last point, and we start with actually 3 people who get on the bus, then we have an occupancy between the first and second stop of 3. Second, and the second stop, there are also 2 people getting on, but no one is getting off, so we have an occupancy of 5. And so you can proceed to have in the third stop an occupancy of 4, the fourth stop an occupancy of, I don't know, 2, to end with an occupancy of 0. So what's actually occupancy is just the total number of travelers on a vehicle, but within the 2 stops. As that is clarified, we can try to calculate it. Now, actually, as the Lijn has a number of paying options, you can relate occupancy to the way travelers pay, and as such, you can divide occupancy in a number of components grouped by the paying service or by the paying method. And the first 2 methods there are subscriptions and smart tickets. And the particular thing about this is that they are delivered by a kind of card, the MoWeb card. And every time such a customer which has a subscription or a smart ticket, every time it's entered on a bus, he needs to scan with his MoWeb card. Those scans are gathered by us, and based on those scans, we can actually build a kind of MoWeb occupancy. The other ways of paying, however, such as, for example, SMS tickets or tickets paid by a bank card, or even worse, people who have a subscription but do not scan at all, or people who do not pay at all. We just don't know. We know a little bit of them, but too less actually to build an occupancy on it. So we proceed with the MoWeb occupancy because that's the one thing, that's the first thing actually we could really calculate. As I told, we only get scans when we get on. We do not have any scan at all when we get off. Question there is, how can we determine, and can we actually determine the exit stop of a traveler? That exit stop is really important, as explained some slides before, because that leaves us to calculate the occupancy. Meaning we need to build actually somehow an exit algorithm. I will explain it very basically, the exit algorithm. First of all, suppose here we have one specific trip of 5 stops from A until E, and we have one traveler which is getting off at stop A. That's a thing we know, because then at that moment he has a scan. But we actually don't know where he will get off. What we do know, or what we do assume to build an exit algorithm, is that actually most of our travelers take the trip in the 2 directions, so back and forth. So if we assume that, we know that that same traveler will somehow, some hours later on, will take the same route, but in the opposite direction, and take actually here stop D accent as the start stop, would say. Then we also know that he will get off, or probably we assume that he will get off at stop A accent. So what we then do is relate those 2 scans that we see. We see the scan at stop A, and we see the scan at stop D accent. And we will relate those 2 scans by saying, okay, the stop which is most closely related to the stop D accent, but in the opposite direction, it's stop D, and will give us actually our exit stop for the first scan. for the second scan, an A accent and D accent, we will do the same reasoning, but in the other direction. And we can say, okay, most probably A accent will be the exit stop. If we only have one stop, this is mostly reasonable, but in practice, we of course have multiple stops. And for each of those stops, we attach a kind of scoring logic behind it to derive the most probable stop to determine as an exit stop. Okay, so here we are actually. We have derived our MOBIP occupancy, but the question is then, is it enough? No, because actually we do need total occupancy. And here we depict it. On the y-axis, you have the occupancy. On the x-axis, you have the number of stops by sequence, the stops actually by sequence number. The blue line is a MOBIP occupancy, and the yellow line is a total occupancy. What we can calculate now is a MOBIP occupancy, the blue line. What we want to calculate actually is a yellow line. And therefore, we need somehow a kind of extrapolation trick to go from the MOBIP occupancy to the total occupancy. But more important, yeah, it's okay, Alexander. but more importantly, to build actually a kind of extrapolation model, we need some data. We need somehow, somewhere, the truth. And question mark is, what is the truth? It was actually one of the most difficult steps in our process, is how will we build the extrapolation model? And the answer came finally mid-summer, I would say, in the form of the camera data. What was the camera data? It was a kind of proof of concept where 15 vehicles, 13 buses, I think, and 2 trams were equipped with cameras. Cameras actually counting, as you can see here on the picture, cameras counting people going on and getting off the bus. No pictures, just counts, and delivering actually for us for the first time structural labeled data. So really nice. However, there were some drawbacks on that camera data. First of all, we only had data starting from June 2020. It was only on 15 vehicles, and it was only on vehicles which drove in Ghent, Antwerpen, and surroundings. So we had to make there the assumption that the behavior in the other regions were comparable, an assumption which actually we couldn't test at all at that moment. Furthermore, we had some quality issues, and sometimes we hadn't any data at all. And as you can see, Alexander picked there some figures. When we then investigated the buses themselves, we saw that the cables, for example, were just put off and that we have no camera data at all. So we had some problems with the cameras themselves. Yet, it was still the best we've got because it delivered us some structural labeled data, and they were promised more vehicles. And they will come also because in 2022, they promised us 50 vehicles, which would be enough to to make a representative labeled data structure for whole Flanders. Okay, there we were with our MOBIP occupancy, with our labeled data. But with actually no time because we were midsummer and we had to deliver in September. That's the reason that we proceeded at that time with a very simple matrix logic to build to extrapolate MOBIP occupancy to the total occupancy. What does that mean? That we had some 4 categories: region, time window, vehicle type, and day of the week. And within those categories, we just related based on the labeled data that we had, we related actually the MOBIP occupancy to the total occupancy, and we extracted some extrapolation factors. The reason, as I told, was really the timing, but also the restricted amount of data at that moment because we only started to gather data in June 2020. Luckily, in a second build, which went live April 21, we proceeded to a kind of machine learning algorithm as we had more than enough data to do that. We built more than 2,000 features, and we built actually a CloudBoost algorithm to have a more satisfying extrapolation model. Of course, the issues with representativity stays, but as I explained before, we will have some more cameras in 2022, which would solve this issue too. Okay, we have our occupancy from the past. Question now is, how can we translate it to our future occupancy, or how can we predict actually? To explain a little bit how big the problem here was for us is that to forecast the occupancy, we need to forecast actually every departure in the schedule. And a departure in the schedule is actually defined, first of all, by the route, as you can see here, because I depicted a slide of the schedule and Kiewit Station. Second, all by the stop, and of course, also by the timing. And also, Alexander has shown a slide really in the beginning, showing the number of stops and showing the number of departures on weekdays. But on weekdays, we have more than 1 million departures, meaning also that we have more than 1 million predictions to make every day for one day. So again, quite a big problem, of course, quite a large problem with a restricted amount of time, which leads us also to decide to go for a business logic and not for a prediction model in the first build. And with that business logic model, we forecasted 7 days. We forecasted for 7 days based on the schedule. What did we do there? We just look back. So for every departure in the schedule, we look back 2 weeks for similar departures. And what was a similar departure? A departure was similar on route, of course, stop, but also on time, also on day of the week, and on a school day or a holiday. So for every departure, we took our similar departures. We took the maximum of the occupancy we saw there, and we had our prediction. Why we took there the maximum, for example, and not a median or a mean? Because we saw some underestimation if we went for a mean or a median. Well, we were in a COVID period, and it was more likely to say that the bus was crowded, while it was not crowded, than the other way around. So we have chosen the maximum, really knowing that at that moment we had some overestimation, but it was allowed due to our just COVID virus. Again, we choose this business logic because it was simple. It was really easy to implement within our existing CI/CD pipeline, and it was feasible within the timings. But also here we went further to a third build, not in a second build. There we left the business logic as it was. But in a third build, which is live from August 21, we made a combination between a business logic model and a time series prediction model. Why? We changed to really time series prediction because our business logic model was a very good baseline, but there were no improvements possible. What did we do then? For every route stop combination, we made one model. We did that with profits. And as a result, we really had many models. Why we did it like this? Because profit allows us a really fast retraining, an explainable model, which was really important for our business, and of course, also an ease of tweaking. In addition, we made it possible to do it like this, as our CI/CD pipeline we had for ETL jobs was also ready to take machine learning models with also a continuous training pipeline added to it. And then occupancy was not enough because we really would like to go to crowdiness so that we could show some explainable categories to the travelers and not only just one number. For that, we needed to go from occupancy to crowdedness. And as you can see here in the first figure, or in the first figure, you see a bus with not many people, so you can really say it's not crowded. In the second figure, you see a really, really crowded bus, so that's not difficult to say it's very crowded. But on the picture in the middle, it becomes more difficult because some people will say, yeah, for me this is crowded, and other people will say, no, this is okay. So how will we qualify this figure? In addition, it does not only stop with the number of travelers, as you saw in the pictures before, crowdedness also has to do with some capacity, with the number of seats and with the number of standings. So somehow we will have to relate those two numbers. We will have to relate occupancy on the one hand, with the capacity on the other hand, to have some really good definition of crowdedness. And to do that, first of all, we went to the app team, which was building the crowdiness score into the app, and we discussed how we will depict actually the categories to the customers. That was the first thing that we did. And then we came up with those 4 categories, namely the green category was saying many seats available, the yellow category, some seats available, the red category, only standings, and then the really red category was just the bus is as full as possible. Based on that, we just made our crowdedness score, which was occupancy divided by 2 times the seat capacity. Why we decided for that formula? Because it was really easy then to translate that score to the 4 categories as depicted there. Because 0.5, a score of 0.5 means really no seats available anymore. And a score of 1 means that you have at least 2 times as many travelers as seats available. So check. We have some explainable categories to the customers, and we are able to translate our occupancy to those categories. Just some remark to end this thing on crowdedness. Although we can do our best to say how crowded it is on one bus, there is still the perception, of course, of the travelers. And for example, what do I mean with that? This figure is very clear that it is a very crowded bus. So the category will be 4, the most crowded category as possible. And the perception of the people will also be full. While at the other side, the perception of some people will still be full, while the category will only be 2 or 3. So there will always be some kind of misleading fact by the people themselves and by the categories. And to end my story here, did we evaluate this whole setup? Yes, we did. And was it good enough to go live? First of all, I will just do a recap of all assumptions and errors we've made during whole that process. In the first step, we made an exit algorithm, we made an extrapolation algorithm, and we had some issues with the representativity of the regions. In the second step, we did a prediction actually. And what I didn't really mention was that we base our prediction on the historical occupancy, but the occupancy, we treated them as being the truth, but actually it was not really the truth because it was already a prediction themselves. And in the last step, we built a crowdedness formulation. This was really an assumption, how to relate it with the seat capacity. This whole setup, we tried to evaluate it on 2 different options. First of all, our validation was on the final score, meaning the correctness of the crowdedness category. We checked the camera data, which we had for the regions in Ghent and Antwerpen, and we did a tally in the other regions in September 2020. The results were that we overall were more than 70% correct, with a higher correctness at the low crowdedness categories and a correctness of more than 50% for the high crowdedness categories. And when there was a mismatch, it was mainly a mismatch in neighboring categories. What do I mean with that is that, for example, if we said that it was category 3, then the true category could be 4 or 2. And also we had our known overestimation. Thus we had more, if we said that it was 3, it was more or less 2, or the other way around, but it was more 2 than 3. So good enough to go live, and we went live in October, not in September, but still in October. Alexander, it's yours.
All right. Yeah. And now for the last step. So we have our results and we have our models. Now we have to get these towards the data, towards the client, towards the end users. How do we do that? So the first implementation that we made with the app. Of the app of the Landstory, as you see here on the right side, we have the small symbols. We have it's 2 parts. So we have the API ourselves that we built that the app team can query, and then you have the app team itself, which visualizes it. So I'll just show the flow how we set that up technically. So we have it's all done in a nightly batch job. So our main scheduler is Airflow, like a lot of other data platforms that I know, and we decided to keep Airflow as our main scheduler, even though Azure Machine Learning has its own scheduling mechanism. So we trigger the training and of the models from Airflow towards Azure Machine Learning, which will train them every night. We have a different category of some models, and these models will be dumped on the S3 on blob storage of Azure. Then there is another job, an Azure Batch job, which is a very low cost way of moving and calculating. Of doing compute in Azure. This draws in all the data that it needs. So that's like vehicle data with capacity on it, stuff like that, planning data, and also, of course, all the models that have been done in the job before. And these results of the resulting, these resulting crowdedness scores will be put into a Redis, which is an in-memory cache, which responds very fast to calls. So then we have the other side. So when the data is there, when the app comes, when the app starts and somebody loads the screen, then the app does all the API calls through an API management portal from Azure over to an app service, which runs Fast API, which is a Python framework. We're pretty pleased with that, and that is the calls towards Redis. As I said, we chose for Airflow to do our scheduling itself, just to have a single point where you can view all the successes and all the flows that you have running. So as well for all the ingest of the data, transforming the data, and the models themselves, as inputting it into the Redis. This makes sure that we don't have time window-based dependencies on the different jobs. We just have one big graph which can communicate when it has been succeeded or when it failed. And of course, we are for more than a year, and this is a typical week that we have. So that's more than 2 million calls that we received on 1 week, and you see clearly the different the peaks in usage. So that's always in the morning and in the evening, except on a Wednesday, which is here where you can clearly see all the kids going home. So yeah, it works pretty steadily and it's pretty responsive. So we're also still hiring. We're always looking for new people, so you can always send me or Joachim, who is our product owner, a message if you want to join. And if there are any questions, feel free.
All right. Thanks very much, Alexander and Elle. I'm going to put thingy again. No, not this thingy, this thingy. Yeah. So we have one question from Bruno already. Bruno says, in the third build, you mentioned you deploy one model per route stop combination. How did you deploy that many models? Did you hit any quota or API limit when deploying that many models?
Yeah, actually, we did not really deploy the models because we didn't use an API. Let me say it like this. Our deployment was registering on the repo of Azure Machine Learning, but only registering when the models were validated. Let me say it like this. So they were validated on an automatic cycle. And once they were in the register of Azure Machine Learning, we could use them in our batch job at night, but just take the model and then did the predictions which were necessary.
Okay, cool. While we wait for other questions, I maybe have a question. So imagine, like, I like the journey that you brought, right? So now let's just say, for the sake of the argument, that your predictions are 100% correct. And all the time, whenever I take a bus, I can see how busy it is, and it's always bam, spot on. But then what do I do with that information? Is it the next step that you're going to provide me with alternative ways of how to get there? Because if I have a bus, I have a bus to take, right? It's like, yeah, too bad. It's going to be busy. No.
Yep. The next step is first of all that within the app and also on the web, that they make more advanced usage of how you can use it to reschedule actually your bus or your planning. For example, if you see that your bus is crowded at 9 o'clock in the morning, and perhaps it's better to take the bus at 10 o'clock because at 10 o'clock there is less people on the bus, or the other way around, it's not crowded yet, so start today. And the second option is indeed to do really a replanning, but with the buses this is quite difficult because most of the time you should be happy if there is one way where you can go to your to your destination. It's not that easy to reshuffle. Let me say, take a whole other way with the buses.
No, I think the Lijn also owns the bicycles, right? The blue bikes, or am I mistaken?
That's true.
Yeah. So that could be an alternative. Like, hey, I know it's super busy, but there are still blue bikes available. It's not raining, so just take a blue bike. It would be more pleasant for you, right?
Yeah, indeed. That's true.
I don't know. It's just a suggestion. Yeah, okay. All right. Okay, there are no more questions coming in. Then, Alexander, I have a question for you. Although I know a bit of the backstory of the project, right? So it's a bit of an insider question maybe, but you said on your slide that you use almost all Azure technologies out there. Like you have like on your architecture slide, you have quite a few of them. I know. I mean, over time, how does this evolve? And are there technologies that you say, like, in my next project, I definitely want to reuse those again because those are awesome? Or are there others where you say, like, they're there, but if I could do it again, I would kick them out?
One which I was always, in the beginning, I was always very, touchy about. I didn't really want to use it because I had a bad experience with NiFi, but Data Factory is an awesome tool. It ingests everything. It never let us down. In the 3 years we used it, it has pumped over terabytes of data, and it never fails us. So that's really awesome. And also Azure Batch. It is a lot of maintenance. You need a dedicated data engineer to keep it up, but it's super cheap. It works super fast. It's an awesome service. Yeah. So.
Okay. And you would say you need an engineer to keep Azure Batch up?
Yeah, not full time, but somebody needs to know for the small times, and like as well within Airflow, it's not as a service, so something will sometimes go wrong, and then you have to look into it. But that's also the reason why we use so much SaaS. We're a small team, and the SaaS products do work. Sometimes it's you have to really dig into the corporate documentation of Microsoft, but in the end, it always works.
Yeah. Okay, cool. Thanks for sharing. Istvan asks, I'm not sure if this is a real question, but Istvan asks, so your forecasts are self-destroying?
No, actually, every 3 or 4 days, we retrain the models. But every night in a batch, we make a new prediction. So those new predictions are, overwriting the old predictions for the next 7 days. So every day, we have a new prediction for tomorrow within 6 days or 7 days.
Okay.
But I don't know if this is really asking or answering the question of Istvan.
Yeah, I'm not sure, Istvan. Maybe you stop drinking so many beers, Istvan. I'm not sure what you mean here.
Could be,
All right, cool. I think with that, we can also wrap up this session, unless there are some more questions coming up. I'm going to add the other speakers to the stream again. So, Jellert, Lander, Sarah. One of you left. Who left?
Simon left, apparently.
Simon left. Okay, yeah, that's fine.
And by the way, Istvan, keep drinking the beers.
Yeah, I actually had the IPA, and that was really good. I really like the IPA. Now I also started the triple. The triple is less my cup of tea. But the IPA, for the other ones listening, the IPA is really good.
Right.
Okay, Chris, can I just answer on the question of Istvan, because he
go for it.
Explained himself, or Andreas helped them actually. Yes, it will take some time, a few times or a week, but then normally the models would as they are retrained, and if there is another trend, you would correct themselves. I would say like this, but the first few days will be wrong, of course.
Yeah, okay, got it. Yeah, now I see as well the comments. Yeah. But in the end, your prediction might be less correct, but your service to the people is better, right? So that's
sure.
what you want. Yeah.
That's true.
All right. Well, with that, I would like to wrap up this digital meetup. Let's see in April. What am I saying? In January, how the COVID situation looks like. We plan to go back live. I think people like to do that. We also did a live stream while we're being live, so I'm going to try to set that up again if we're live. But if there are still like hospital beds, if the hospitals are still overcrowded and we need to postpone healthcare, then we're not going to organize physical meetups, right? So let's see what it will look like in January. Once again, Sarah, welcome to the team. So this was your this was your talk at the meetup, but you're going to see Sarah a lot more helping us organize the meetup. So thanks a lot for that. And thanks to all the speakers. So there were a lot today. Fortunately, Simon already left, but so Sarah, Alexander, Elle, Lander, Jellert. I liked it that all talks were from relatively large organizations in Belgium. And it's cool to see that how data science is being used in real life in also these big organizations. So it's not just the startup hippies that work with that. So I learned a lot today. So thanks all for sharing. Yeah, and I hope to see you next time, well, in person or on the YouTube stream again. Thanks all for joining. Take care.
Thank you. It was a
Thank you.
pleasure.